Hey guys, I wanted to go through one more time a little bit about the Levers Lab, and I wanted to do it using a screen recording so that any lag that you would have experienced during the class hopefully will be negated or canceled out. As you see right here, I already opened it up to the lab 6.04 Levers Lab. As you can also see, the due date has been updated to where it is due October 17th at 5 p.m., which is next Tuesday. That's because this lab includes both information from 6.04, the Levers Lab, but also from 6.06 and 7, which are the Pulleys Labs. So let's go ahead and open this up. First thing, like I always say, is you download the student guide. If you click that lesson introduction on the third page, you will see the student guide right here. You click it, it will open up a PDF. The lab report for the levers is right here in this same folder. I just click it and download my document, and we have a nice pretty little lab report right here. First thing, looking at the student guide, it says that you need to open the Simple Machines virtual lab, click View Tutorial, and complete the tutorial on how to conduct the lab. So where do you find that? Go back to your page, and underneath the investigation on the second page, so wait till it loads up, page 1 of 2, we want to be on page 2 of 2, there's a link to the virtual lab. It's going to take us somewhere a little different. Alright, so this is our virtual lab. I'm going to do it this way so that hopefully you guys can see it a little bit easier. Alright, you need to view that tutorial. I'm not going to do that because it's a waste of time essentially for me. So I'm just going to go straight to begin the lab, and I'm going to pop back to the student guide to see what it tells us to do. After you have finished the tutorial, you're supposed to write the goal for the lab and a hypothesis about the relationship between the levers and the work on your lab report. So open up that Word document for your lab report, and you want to write in what is the goal of the lab on levers and pulleys in the question you tried to answer. So you're going to write in your answer there, and then what observations, experiences, or lesson materials help you form a hypothesis. Number 3, what is your hypothesis? But this is essentially where you're going to get started. So let's open back up that virtual lab and we can get to work. So the first thing you need to be aware of is that the table that's on your student guide looks a bit different than the table that is on your student guide. Okay, this first part, it says notice that the level is a large one, so the mass of the lever needs to be considered in all of these calculations. To do this, first set up the lever so that the spring scale is hooked to the resistance, and set the fulcrum 10 centimeters on the resistance side. Place no mass on the effort side. The reason why it's doing this is it's trying to tell you how heavy, or I want you to figure out how heavy or how much force is going to just be the weight of the lever and the weight of the spring scale that are on there. But you don't really have to worry about that because in the second part it tells you the force applied to the balance with the lever and no mass. So it gives you the answers. So actually you can skip over section 6. Our effort side is going to be our left side and our resistance side is our right side. So effort side's this side, resistance side is right side, okay? You can grab your little guy and you're going to throw him up, and you want to measure everything with 300 grams, which is the middle guy. So you're going to get him, you're going to drop him down. So if you didn't know where I got that from, I got it from right here. Complete the data table using the 300 gram mass and varying your fulcrum position as shown. Okay, so the first thing that you want to do is you want to look at what it's asking and how you can answer the question that it's asking. Okay, so it says you're going to have a 300 gram weight. We did that. Check. It's giving us how much force is applied to the balance, so we don't have to worry about getting that like in the last question, like in number 6, what it told you on the student guide. But what it is asking us to do is that we, on our effort side, the left side, we have an arm length of 0.7, and on our resistance side, the right side, we have an arm length of 0.5. So this is our right side, and this is our left side of the fulcrum. Okay, the fulcrum is the point that it pivots on, right? So let's go to and open up our lever, and we want a 0.7 arm length on the left and a 0.5 arm length on the right. 0.7 on the left, how do you do that? Well, there's 60 centimeters between here and 0, so how do you make it 70? 0.7 meters is 70 centimeters. So you're going to add 10 centimeters to it to make it to 70 total centimeters. So if we zoom in and we look at this, we have got, back up, okay, we have got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. 70 centimeters on the left side, or the effort side, and then we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 centimeters on the right or resistance side. Does that match up with the student guide? Let's see. 70 on the left, 50 on the right. Perfect. Okay. Go back. What we want to do now is we want our table to be horizontal. So I'm going to grab it. I am going to try and make my table horizontal and leave it there until the numbers stop moving. Alright, so I got 5.23. Alright, so drop it, and then you're going to write that down. Pulling force right here on B, pulling force applied, 5.23 newtons. Okay, so it's asking us on the effort side, on the left side, how much force is going into it. So you have two parts that are factoring into it. You have the weight or the mass of the little 300-gram mass part, and then you also have the length of the arm that's in there. Those are both parts that are factoring into how much work or effort is going to have to go into it, okay? So the way that you do this is actually the easiest part, and you can go ahead and do this ahead of time for all of them. You pull up your calculator, and you're going to use 2.94 for your newtons, and you're going to use your number so everyone should have this number the same. Okay, now whenever we were going through it before, I think that I told you guys to use the other number for the one that you pulled down. If you'd use that number, that's fine. Okay, you're not going to get anything taken apart, but you do 2.94 and you times it by your arm length, which is going to be 2.058. Since our significant digits is only 2 decimals long, then we are going to have to round it up to 2.1 joules. I'm going to go ahead and go through and do the rest of these. Okay, so now that we have all of our calculations for the effort side, we are pretty much done with it, and we get to move on to the other side. So whenever I did the pulling down with the spring scale, where I had 70 on the left and 50 on the right, then I pulled down and I had a 5.23 Newton reading on my spring scale. Now, there is an error right here as well, which I went over in class multiple times, but the total force felt by something is going to be the bigger number minus the smaller number, so it's actually B minus A. So in this case, our total force would be 5.23, because it's in column B, minus 0.87 because it's in column A. Okay, so you put that in your calculator. 5.23 minus 0.87, and you get 4.36. Alright, so 4.36 is our total force felt. 4.36 newtons. And then it says for the calculations, you're going to do work equals newtons times meters. If you converted yours to centimeters, it's fine as long as all of them are the same. Okay, so 4.36 times 0.5. And that's going to be, clear. 4.36 times 0.5 equals 2.18 joules. So essentially I just went in and I put in numbers for things that whenever I was experimenting I got the answers for. Okay, so this is the student lab or the student guide, okay? Now you have to put all of this information into the lab report, which we already together did some of it on our own, right? So together we already filled out some of the answers on the top, but now we have these answers on the bottom that we need to use. So the very last final step in completing this portion of the lab report, number 4, is for us to copy all of the information that we did and we obtained and put on our student guide over onto our lab report. So a lot of people freaked out and they're like, I don't understand how to do this. Well, if you look at this, you have 3 columns over here, and then you have 3 columns. Well, you have multiple columns over here on the right. So essentially what is this is columns 1, 2, and 3 right here are columns 1, 2, and 3 over here. Okay, so you have 300 grams. See how they come out together? 300 grams, 0.7, 300 grams, 0.7. So you just want to copy over your information over here. 2.1 joules, 2.2 joules, I have 2.4 joules, and I have, last but not least, 2.5 joules, right? Those are my answers for those. Now, what about the right half? Well, see this right half? It has column A, column A, column B, column B, B minus A, oh, B minus A, arm length, and work. So you literally are just typing and copying over your information. Okay, once you get these, I'm not going to do all of them. I'm just going to do one of them to just make sure that you understand the way that you do it. And once you are finished, then you are finished. And what you need to do is make sure that you save this to somewhere on your computer that it's very easy for you to access and find again, because for numbers 5 and 6, we will be doing them on Monday and Tuesday when we have the pulleys lab, and we're going to have to go through all of this with them as well. So make sure you copy your information over from your student guide onto here, and then you are good to go. As always, if you need help, come to a live help session, send me an email. Please be sure to try and watch all of the recordings and do your best on your own. And whenever you get stumped, feel free to reach out to me. All right, good luck everyone, and I will see you next week.